Welcome to qnawire.
Hi there. So for this problem, we have an positron-electron annihilation, as is shown in this figure, and it occurs at 3 centimeters from the center of the light connecting two detectors. Now, we know that the resultant from this are two photons, also 3 centimeters from the center. And the question is if the resultant photons will be counted as having arrived at this detector simultaneously. So we are given some options and we need to calculate that time. So as we can see from the picture, we're going to call this photon, the one that is farther from the detector, 1, and the one that is closer to the detector as 2. So the distance that the photon 1 needs to travel to reach the detector is going to be L plus 3 centimeters. Meanwhile, the photon 2 needs to travel just L minus 3 centimeters. So the distance D1, I'm gonna call that with a lowercase d, D1 is L plus 3 centimeters, and the distance to is L minus 3 centimeters. Now we note that the time is the distance travel over the speed, and we know that in this case photons travel with the speed of light. So the time for the first photon, the one farther from the detector, is going to be d1 over the speed of light, or L plus c3 centimeters over c, and the time that it takes for the second photon, the closest to the detector, is going to be L minus 3 centimeters over c. So the time interval in this case is the difference between these two times. So we will have that time interval is T1 minus T2. So we introduce these values that we obtain. So for T1 we have L over 2 plus 3 centimeters over C. And for T2 we have minus L over C plus 3 centimeters over C. As we can see, the terms related with the distance L cancel each other, and we will have that this interval of time is equal to 2 times 3 centimeters over the speed of light. Now, we just simply need to plot these two values. So we need to transform centimeters into meters. We know that 3 centimeters is, we just divide that by 100, and so we obtain 0.03 meters over the speed of light. And we know that the speed of light is 3 times 10 to the 8 meters per second. So plotting this into the calculator, we note that the interval of time, or the difference between one photon and the other to reach the detectors, is 0.2 nanoseconds. But we know that there is a window of 10 nanoseconds for the detector to detect if two events occur at the same time or not. So as you can see, delta t, the time that we obtain, is less than that value. So the correct answer for this problem is D. That is that the photons will be counted as having arrived at the same time or simultaneously with a time difference of 0.2 nanoseconds. So that's D. So this is it for this problem.